Hey, how's it going? I am going to do just kind of like a little freeform Git exploration. I started learning about Git, I guess a few years ago when I was still an undergrad. And at one point I was going to give a lecture on it, and I spent probably like a week just exploring it and trying to figure out what makes it work, what the different internals are. And I felt like that helped me a lot. And I felt like there's a lot of weird things that have happened in Git since then that I'm able to resolve because I'm kind of like not afraid of what's going on underneath, like merge conflicts or when I first started using Git, I would regularly just like delete entire repos and start over again because I'd be like, oh no, like I broke something, I have no idea what's happening, let's start over. And I want to kind of get enough, yeah, just present enough info of what's happening under the hood so that you can at least start to read the man pages and maybe think your way through what's going on. So, uh, as I said, this is going to be kind of freeform. Um, I actually haven't seen anybody else explain this quite like I'm going to explain it. I'm sure other people have. I just haven't seen it. Um, so yeah, I'm going to start off by making just a directory. We'll call it just my repo. And so we have a fresh Git install or a fresh Git repository. And we see that this is basically comprises just a single .git directory. And this is when I talk about the Git repo, this is what I'm talking about. A lot of people thinking about the working tree that they have. The working tree are just the files that you're interacting with, like the version of your project that you're checking out at that given point in time. That's not what I am thinking about when I talk about a repo. I'm actually thinking about this directory. And let's start off just getting kind of accustomed to some of the things that are here. We have this head file, and it right now just says refs heads master. You should recognize master just from kind of like just general Git usage. We have this config file, we have a description, we have hooks, info, objects, refs, and we're going to be looking at, I actually don't know what all of these things are, but I know enough that we're going to be kind of looking at what some of these things are and trying to understand how they let us use Git from the command line like we're used to. So to start off, I want to. I'm just gonna make a little file. I'm gonna just echo first line into a.text. A Git add a.text. Sorry, my terminal's a little bit laggy today. I'm not sure why. I'm converting a video file in the background, so that might be it. Okay, and let's go ahead and I'm going to list the .git directory again. And notice that we have a new file called index. Um, and that wasn't up here before. If we look at this from, yeah, no, the previous listing that I had of that directory, that index file wasn't there. I'm just going to cat it. And it's nonsense, right? There's nothing here that makes any sense whatsoever. It's just a binary file. But if you look a little bit closer, there actually is this a.text. Yeah, and so that's like our first clue of what's going on here. This is what we call the staging area. The index file, when we talk about the staging area in Git, remember we have this two-part system where we stage things. You know, we have these new edits and we stage them and then we commit them. And so adding stages things and then committing, stores those into the actual repository. And then, any pushes or pulls are going to have that committed thing in the repository. So this staging that we do actually puts a.text into the index. Now when I run git, and I'm just going to list a couple of other things real quick, and we'll see what happens. I'm going to list .git slash objects. And now I'm going to go ahead and run a git commit flag m, and I'm just going to say first commit. And I'm going to list objects again. And we see that we have some new things in here. We have a 47, a D2, and a 96. Now, I'm going to run this. I have a special git log command that just makes it more printable. I'm going to run that git log, and we see that our commit now has the commit hash that starts with the D2. Okay, and the remainder is FB668. Those are just the first few digits. Well, look here, inside of .git objects, we have this new directory from that commit that starts with D2. Let's list that same, let's go ahead and look at the contents of that directory. Oh man, this is a file that actually just starts with that same hash. So this is how Git is actually using those commit hashes. The first two digits is just a directory, and then the remaining digits of the hash are a file name. And if we cat.git.objects.d2.fb6, we're going to get some binary nonsense. And it's compressed. This is more than just the contents of our file. This is also metadata about where this commit object fits inside of the commit history, when it was made, any commit messages. So there's a whole bunch of data in here, and it's all compressed. Okay, so right off the bat, we now have a better understanding of what a commit object is, right? It's just a file with some metadata. And I don't know all the metadata that goes in. There are ways that you can look at that, just kind of decompress this. I don't know how to do that off the top of my head. It's not super important. I've never needed to do that. But I think that this is really cool, right? This, to me, immediately demystifies a whole lot of what's happening inside of Git. Okay, we also, I want to talk about refs. A lot of people don't know what refs are. So I'm going to actually dive back into my Git directory. I'm going to list again. Oh, real quick, index. Let's just look at that index one more time. This is a binary file, so Vim's not making it look super pretty. But this is a lot more than we had before, right? We still have this a.text, and we have some more metadata. We have this, there's nothing in the staging area, but we are keeping track of some working tree information. There's just and it's been a minute since I've looked exactly at. I actually did write a little parser for the index file. It was a little buggy, but that could decode exactly what all this nonsense was. And it's been a couple of years since I looked at it. But it's a cool thing to look into at some point if you're interested. I always like seeing how data is serialized. It can be, it could just be interesting to be able to see, again, just how something is implemented. So if that's something that interests you, be happy to talk more about that, or dig up some of the old code that I wrote that parsed it. And there's plenty of documentation out there. So the next thing I want to look at is refs, and we see that there is this refs directory. So I'm going to cd into refs, and we have two types of things: heads and tags. Tags should be empty, but heads is not. And I'm going to go ahead and cat heads master. I always laugh at cat heads. I don't know. So if I giggle to myself a little bit, that's what's happening. So the this is that hash we just saw a second ago. All that refs is it's just a file with a commit hash. That's it. It's literally just, you can think of it as a pointer. It's just pointing to the commit object that we care about. And so that's all that master is. It's just a file with a commit hash in it. Okay, and let's come back here and let's cat head. And we're saying it's a ref, right? Head is pointed at a ref, and that ref is inside of refs head master. And that's the thing we just looked at. So if I so remember we have the head file, and it's pointed at refs head master, and that's this refs head master. Master is just a file inside of refs, and it's pointing to this commit hash. That's just a file with this commit hash as its content. That's it. That's a huge part of Git right there. Okay, so let's say I'm going to make another commit here. I'm going to open up a.text. Let's see, this is incredibly laggy. I think I'm just running too many things on my computer at once. I can tell even when I'm plugged in, my battery is still draining, that I'm doing too much. But okay, so I'm going to say important second line. There we go. And so I'm going to commit a.text, and it's going to ask me for a message, and then I'm going to say, very important stuff, do not lose. Run git log. Great, we're there. Just to sanity check ourselves here real quick, I'm going to git log 6795 dd4. That's the current commit hash we're on. And I'm going to cat .git /refs heads master. And we see that that's the commit hash that's stored inside of master. Now, what happens if instead of checking out master, what if I'm going to copy this. I just want to kind of, here, I guess I can command C it. I want to check out this commit hash directly. So we get this huge output. Note, switching to 6795 DD4, etc. You are in detached head state. You can look around, make experimental changes, and commit them. And you can discard any commits you make in this state without impacting any branches by switching back to a branch. You want to create a new branch, etc., etc., etc. So let's look at what's actually happening under the hood in a detached head state. This is a thing that I feel like a lot of new Git people come across, and they're like, oh my god, detached heads are bad, right? Like detached head is like a very bad thing. You don't want it in most situations. In this situation, in Git, it ends up being totally fine. So I'm going to, again, list.git/head. And, sorry, I should cat that. I want to cat detached head. And remember before we were saying it's a ref. When we cat head before, it output ref : and then refs/heads/master. Now we just have a raw commit hash. And if I run git log, we see the same thing here. That my head is no longer pointing at master. There's two different refs. Head is, you can think of a head as a ref that normally points at other refs, but now it's not pointing at another ref. It's not pointing at the master ref. It's just pointing at that raw commit hash. So when you get to detached head state, all you need to do, I've actually never done this before, but let's try this. This is a bad idea. But let's actually just say, I'm interested to see refs heads master. I'm going to run git log. Look, now it's pointing. Now it's pointing. Hell yeah. So we just did a checkout just using Vim. We just vimmed the head file, and now we're pointing at the right place. I guess you can't really see because my camera's in the way. Can I move that? I don't think I can move that. Sorry, yeah. So yeah, we see that head is now pointing at master. I am going to Yeah. How do I? Ooh, I have it. I have it right here. I'm going to undo this, and there's a reason I'm going to undo this. Um, I'm going to vim in here. Okay. And if I run git log again, we see that we no longer have that arrow. The reason I'm going to undo this now, well, we'll see in a second, but I am going to, yeah, there are some log files that we care about. And I want those log files to be preserved. So I am going to, let's say I do something stupid. I have this commit, and let's say I delete it. I'm going to check out master real quick. And let's say I get reset hard head. And so just some syntax real quick. Reset, I'm going to basically undo the changes I did on a commit. And the hard option means I'm going to undo those changes. Well, first, let's see what happens without the hard. I'm going to reset, no hard for now, and I'm saying head and then tilde. And that head with a single tilde says take the head and then go to its parent. So in this case, we're going to go to our first commit from our second commit. Head is currently pointing at our second commit, and head tilde is going to point to the first commit. And now we have an unstaged change. I'm just going to run git log. And master has actually gone back one. And we still have, luckily, right, a.text. If I cat a.text, we still have that important second line. So it's still in our working tree. And if I run a git status, we see that it's modified. That the change, I've undone the commit, but I haven't lost the change. The change is still in my working tree. And I can see that if I run a git diff. I see that there's two new lines, and the second one is this, important second line. Great. What say I do reset hard? Now, that commit's gone. Oh no, it's important. I wasn't supposed to lose that commit. What do I do? Well, if I run a git log, it looks like it's totally gone. If I do, yeah, our commit is gone. And through, the basic interface of the git command line, it's going to be really hard to get back there. We could scroll up and, check out. We're lucky that we actually printed this commit hash out. So I can do git checkout. And look, it's actually still there. That commit is actually still in our repository, even though we don't have. So it's kind of like, you can almost think of it as like a memory leak, right? It's still there, but there is kind of no way through the normal git usage to get back to it. And again, I luckily printed out that commit hash up a few lines, but let's say I didn't. Let's say I clear, and there's no, and I forgot that I committed that I printed out that commit hash. So I git log, I can't get there. Well, let's go ahead and check out that .git directory. There is this logs file, or this logs directory, and well, let's first cat that head. It's a little hard to read. There's a lot of information, but this most recent thing that we did was going from that old commit hash to this commit hash. To the remember that D2 et cetera was our first commit hash, and this 6.7 was our second commit hash that we've lost. And so we can look at our head, and if we're clever enough, we can probably figure out why. Yeah, like which one of these commit hashes it was. But a lot of times there's a bunch of commit hashes, and it might be a little tricky to figure out. You can also, let's run ls again. We can also cat the actual master. And here we see that when we get the actual commit, this is the reset. This is the reset, and we're moving to head up one. And we see that we started off in our second commit that we thought we lost, and we ended up here. And so I can go into these log files, copy, and then I need to get back into my working tree, git checkout. Yeah, and then I can just say like git branch master, or yeah. That dash F lets me just force master to be here. Then I can git checkout master, and I'm no longer in detached head state. So the point of all of this, right? Why do we care about all of this? The point is that a lot of people, when you deal with destructive commits like reset, there's this misnomer, there's this myth that we lose all of our information, right? If I do a bad reset, I've lost everything. But no, you have. I mean, we can do. Let's try something else. Git checkout head. Wait, nope, that's not what I meant to do. Git checkout head. Okay, so we're here. I'm going to make a new branch. Git checkout flag B. This is a shortcut. Topic. And I now have a new topic branch, and I've checked it out. And I'm going to echo blarg into b.text and git commit flag m blarg. Oh, wait, git add b.text, git commit flag m blarg. Okay, now we have a clean working tree. We're on branch topic. And if I run a git log, we see that we now have this branching structure. And again, terminal is a little small here. Let me see if I can make that a little easier to see. Right. I'll bring this down just a touch. Okay. So yeah, just going back into our git log real quick, we see that we have, yeah, these two different branches. We have this commit, which is our master. We also have this. We could run a merge. We could also run a rebase. And so in case, I always have to look this up again. I'm going to be totally honest. I never run rebase without looking at the man pages because I don't do it enough. Even if I just do it once a week, like I always just have to double check because rebase is a super powerful commit or a powerful command, and I just always forget it. So I'm just going to go ahead and look at the man pages and just look at how they do it. And they have these really nice graphs. So assume the following history exists in the current branches topic. Okay, this is kind of like what we have, right? They have a couple more commits than we do, but basically we're on C, master is G. From this point, the result of either of the following commands will be this. And this is exactly what we want. We just want to rebase our topic branch onto our master. And so we can just do rebase master. Okay, and now we run git log. And great, head is on top of topic. But let's say, like, you know, the question now is, did we lose the previous branch? We had this branching thing that's now looking like this. Sorry, like that to like that. Did we lose this? Well, let's go ahead and check out. I've never actually done this with rebase. I'm assuming that it's still there in the logs. So there's a few different rebase steps here. But yeah, this was OO commit, git check out, OO, bam, and we're back, right? We still have that blarg commit again. So we actually have two blargs now. We started off with one blarg, and now we have two. Again, it's all in there. And if you know where to look, there's a ton of information. So anyways, this is kind of an introduction to the bowels of Git, the things that are happening under the surface. Uh, I think, just for me personally, this helped a lot. Just knowing how everything kind of fit together. Hopefully it helps you as well. There's a lot more. As I said at the beginning, I didn't really plan out exactly what I was going to be doing, but I did want to kind of give you at least enough tools that, like, if you screw something up, you can get back. Like, don't freak out. You know, you didn't ruin anything. The only thing you can do is, okay, now we're done. Like, you screwed it up. You can't get back. Like, nothing is under version control anymore. But short of that, and the obvious disclaimer, I edited some stuff inside of the .git directory. Don't do that. Like I obviously am working on just a stupid repository that doesn't matter if I screw up, but yeah, don't actually do that. But yeah, everything that you need is in there. And if you ever get lost, don't be afraid to explore a little bit, because yeah, you'll be able to think your way out of it, and just don't be afraid of it. Just try to logic your way through it. Read documents, documentation, read man pages. It can be a little, I'll be honest, it can be difficult. It's not easy to just kind of meet the Git man pages where they are. Like, you need to do some work, but hopefully this will help you at least start to understand how things are working, understanding what a working tree is, rebase, commit objects, these sorts of things, index, staging area, all of that. Yeah, hopefully that will get you a little bit closer. Once you can read some basic man pages, you don't have to understand every single thing that's happening inside of them, but like you can, yeah, at least not be totally lost. Then you can start using Git and you can start really accelerating. And whenever you're lost, you can find your way home. So yeah, anyway, that's it. I hope you enjoyed this, or hope you found it educational, and please hit me up with any questions or comments. All right, thanks.